I'm solving Leetcode problems in this series. So the series is logic building. So you can go there and you can go through like first 25 videos, and first 25 videos explain more about the logics and different techniques we choose to solve any problem. And today problem is a linked list problem. Here it's saying add two numbers. It's a medium level problem. So there are two lists here, linked list here, and we want to add, and that's the result you want to put in a third list. So let's say 257 here, 4610 0, and 1 comes here, 3 that's 448. So sometimes if you read this explanation, it's saying the digits are stored in a reverse order, so that may take some time to think like what it's saying. Let's try to understand here. If you add two numbers, like let's say 342 and 465, then you always start with 2 from the last, like 2, and the 5 here from last, 5 2 and 7, and then go with 6 4. So that's what it's saying. Okay, this is in a reverse order. That means it's in a correct order what we want, like because we want to add this, store it here. So it's already in a reverse order. So it's a 3 4 2. So we are adding 2 5. So 2 is at here, 5 is here at the end. So that's the meaning of that reverse order. So let's try this solution. Let's see the solution I have already implemented in a Golang and Java. So here there are two lists, L1 and L2, and in a first condition I'm checking if both are nil, return nil. Both are nil, like this list nil, this list nil, just return nil. And I'm also checking if this is nil. If this is nil and the L2 second one is not nil, then that's the result, return that. So return L2. And here I'm checking if L2, this is nil and this is not, then return this. That's the answer. So this is the condition for that. So we are done with this. Now I'm creating the new list here. So new list, so that we can store this result. So that's a new list. So create a new list, is a new list head. And also I have to, once I put the item in a first node, I want to move to the next node, and for that I have put another variable, current. So the current and the new list head, initially it both will be at the same place. This is for the carryover. So like if you add this two number and see, like let's say 4 6 10, and we put the 0, 1 is carryover. So for that there is a additional variable, so C. Okay, so that's all. Here we'll see, we are going to iterate through L1 and L2. So we are checking L1 not nil and L2 not nil. So of course L1 is not nil here, L2 not nil here. So for the same now, like if there are three numbers here, there are three numbers, then it will go to the end. So we are traversing, and then we're saying here L1 val, this val, plus L2 val, this val, 2 and 5, and if there is any carryover, that's a C. We add this number and result is here. So we add 257, and then what we do, if the 257, then we are also maintaining the carryover, like 7 by 10. So carryover is 0, 7 by 10. If you divide 7 by 10, it's a 0. So carryover is 0. In this case it doesn't make sense, that's fine, there is a 0. But if you go to the second item, then 4 6 10, then you divide by 10, so carryover will be 1, right? Because in a 10 we want to put 0 here, and we want to add 1 in the next node. Okay, so let's say we are here 7, and then we are also maintaining one previous this variable. We are maintaining previous variable because we know we already created. We'll see that why we need this thing. We'll see in the next step. Yeah, I'll come back here. But for the current node, current value here, if you see, current value is equal to, we have defined, okay, yeah, let's see here, the current, we have already created that node, current node here. So we store the value here, we store the value here, we store the value here, and every time, you know, we are also creating new node here, next new node. Like let's see, like first time we added result by 10, so it's a 5 to 7, and modulus operator 10 will get the remainder 7, so that 7 will go to the this node. So 7 is here, the random value, and in the next, and for the next node we are creating a new empty node, so we created a new empty node here. So in the similar way, you know, if you reach here, we store the value, and then again we create another empty node. So that's why we're maintaining the previous, like previous. So when we reach to this place and we'll see if there is no item, then we can make this next this previous to nil, right? So next will be nil. So for that we are maintaining, and we'll see in the bottom how we do the logic. But anyway, we are here, and we added the 7 in the first node, and then current next. So current next, for this next we added another, you know, another node, and we are saying, okay, next node is current, so we made next node as a current. Okay, and then now we move this pointer to this place for L1, so we say that L1 is L1 next. We move the pointer to this place, L2 next. So in the similar way, all the 3 items, this will be iterated, and will successfully, we can add all the numbers, and we can successfully put all these in the node here. So we are good here, I think this is fine. But sometimes, or see in the scenario where this list is bigger, like let's say this length is 4, like one more is here. So with this loop, you know, we'll be able to store the 3 numbers, but we cannot store, you know, the last number here. Same thing happens here also. Like let's say in this case there will be one more node. So this loop, we are saying L1 not equal to, L2 not equal to nil. So it will go to here, and we add all the numbers, but we'll skip the last one. So in order to handle this last one, we need another check here. So we are saying, okay, L1 not equal to nil. This is L1 not equal to nil. After this, if there is some more item, then I just copied, you know, all the logic from here to here and just put it here. So see the same logic. If you see here, it's a result L1 val C. There is no L2, so I just remove that L2. Then again the same logic here. Previous, we maintain the previous here, and the same thing L1 next. So same thing we did for this L2 also. So if you see here, L2 not equal to nil, again I copied everything here, just put it, only change is L2 val and L2 next. So we handle that scenario also. And then we need to know something like, if C is greater than 0, like all the items we added, let's say at the end there will be, you know, like let's assume there is a 9 here and 9 here, so 9 9 18, so 9 9 18, so we can add the 8, we can just put the 8 to this node in that case, but there is a carryover 1, so we are not handling the carryover. So to handle that situation, I'm saying C greater than 0. If there is something in the carryover, then in that case we can say current val equal to C. We know we already have one additional node, so in that node we can put current value equal to C. But in the case if there is no carryover, exactly nothing after that, then we can say previous next equal to nil. Like this is the previous, current might have already moved to next, so this is the previous. I'm saying previous next equal to nil, so it will just stop here. So that's a solution, and then return new list head. So that's about adding the 2 numbers. Let's see, you know, the Java solution, it's the same. I have checked the logic for if the both lists are null or not. In the case null, return null. When I'm checking L1 null, return this. If L2 null, return this. And then we created a new node. Current, we are also maintaining the previous. Carryover, while for this scenario we have added this logic. And then if there is a more item in the first list, in order to handle that, we have this. And again, to handle this scenario where second list has more item than first list, then we need this logic. If there is something, this I changed a little bit here. If C is equal to 0, that means if the carryover is 0, then next item just want to disconnect next node from here. So the previous next equal to null. In the case carryover, then we know there is an additional node. So on that node, current.value C, return new node. So that's all for today. Thank you.